Okay. As I mentioned, thanks for joining us for session 2 of the ICM Peer Exchange Workshop. We're all excited that you could join us today. We have a few rules of engagement to go over before we get started to help everyone get the most out of today's workshop. Everyone as an attendee will be muted during this workshop, but if you would like to ask a question of any of our presenters, which we highly encourage, we have a couple of options for you. If you'd like to ask a question verbally, all you have to do is raise your hand. If you're on our online meeting, look for the hand icon, which should be located between your participant panel and the Q&A panel. Otherwise, it's going to be next to your name. If you click on that, it will raise your hand. Once I see it, I will address you either by name or if you're dial-in only, I will address you by your partial phone number, and you will be unmuted and allowed to ask your questions verbally. We do ask that when you're finished with your questions or comments, lower your hand again just so we can keep track of who still has a question to ask, and then I will remute you. If you're dial-in only today, we do also have the option to raise your hand. All you'll have to do is dial *3 on your phone. That will raise your hand the same as it would in the online meeting. I'll be able to see it. I'll address you by your partial phone number that I can see in my attendee list, and I will unmute you and you'll be able to ask your question. And then to lower your hand, again, it'd be dialing *3. The other option available to our those of you that have joined us on the online meeting would be to submit a question in our Q&A panel, which is located in the bottom right-hand part of your screen. So make sure when you type your question that it is sent to all panelists so we can all see the question come in. You type the question, hit enter, it submits to us, and we will be able to read it out to to the presenter during the meeting. Things to keep in mind as we are going along, make sure that you keep your questions and responses as concise as possible. We want to hear you, but we also want to be able to address as many questions as possible. We also need to remember that everyone is coming from different perspectives and different opinions on a very expansive topic. So just keep that in mind that what you think of something may not be the same as somebody else's. If we don't get to your questions today, don't worry, make a note of it or feel free to submit to any of our meeting organizers, and we will make time for it during our session 3, which will be held next Thursday. And we will have more time for question answers and group discussions at that point. And I have listed up on the screen the 3 meeting organizers that you can get in touch with. So today's agenda, we will be hearing from 3 different speakers. Brian Carey from Minnesota DOT. We will be hearing from Neil Fobian from Iowa DOT, along with John Mark with HDR, and we'll be hearing from Les Jacobson from WSP. So Neil, would you like to say anything before we get going?
Yeah, I'd just like to welcome everybody again and appreciate everybody coming for our second session here. We heard lots of good speakers on our first session on Tuesday, and I think we got another good list today. So appreciate everybody taking time to join us, and hope they can all return for the session 3, which was next Friday, I believe, or no, Thursday, the 10th. So I guess with that, yeah, we'll go ahead and get started.
Right. Again, like Neil said, welcome all. This is John Mart with HDR. I'm going to get us turned over to our first speaker. So Brian Carey is going to be passing you control so you can start to share your screen, and you can go ahead and get started talking and introduce yourself once you have that showing.
It sounds good. Thank you. Yeah, I'm Brian Carey. I'm the Director of Traffic Operations at our Regional Transportation Management Center, or RTMC for short, here in the Twin Cities Metro up in Minnesota. And bring up my presentation here. We did a pilot project for a ICM corridor a little over 10 years ago now, where we developed kind of a concept of operations and requirements documents. But as you'll see here in the presentation, we never actually officially launched the ICM project on the corridor that we were looking at, but ended up, a lot of the the ideas and concepts that came out of that were developed over time, more regionally, so not necessarily on a specific corridor and such. And so you'll see that here as I kind of get into my presentation. I'm going to stop my video here just so it doesn't interfere with any of the bandwidth here, but thought I'd at least say hi there really quick. So why integrated corridor management? So we have an independent network of transportation systems. We identified that we have a freeway system, we have our arterial system, we have our transit system, and all these are being kind of developed in different silos. And so it really kind of helped get these different groups to work together, kind of coordinate, what would we need on more of a holistic approach to look at managing traffic within a corridor rather than within our independent networks. And we already had, a pretty extensive ITS system out there, really amongst all three different groups. So how can we combine some of those systems and try to optimize the entire system as a whole? And so that's where integrated corridor management kind of came into play, and why we chose to be part of this pilot project that was probably in about 2007 that Federal Highway was leading. And they had brought on a few pilot states. All right, just delay in my slide there. They brought in some pilot states to develop an ICM corridor concept. And so we are one of those pioneer states that started the process. And there was multiple different phases to it. There was a phase one that was to develop a concept of operations and systems requirement. Then there was a phase two that took these pioneer states and narrowed it down to 3 or 4, I don't remember exactly, but where they would model the concepts in a microsimulation model, or mesosimulation model rather, and try to determine, what kind of benefits would we see from that ICM concept that we had. And Minnesota was one of the sites that was selected for the modeling phase. And then when it got into the actual deployments phase, we were not successful in getting the funding. So that's part of the reason why we probably didn't go right into a single corridor like that, but it also kind of changed our focus a little bit, that rather than focusing on a particular corridor, we focus more regionally across the entire Twin Cities metro. And so we have made some progress in kind of developing some of these concepts that I'll talk about here today. We had already had some history with kind of an ICM type corridor, except we called it ICTM. It was on the 494 corridor in like the mid to late 90s that was developed. We had partnerships between MnDOT and the county and a few of the cities along that 494 corridor. You can see there in the map on the bottom, kind of the corridor we're talking about is kind of in the southern metro. The system had a SCAT system for the traffic signals, as well as integrating the traffic signals with the ramp meters. So there was some communications happening between the ramp meters and the signals. There's also a lot of alternate route guidance sighting, like you see in the picture here, where they'd be up on a mast arm. You can see the one example here saying like East 494 is closed, some alternate route with an arrow that would kind of guide people along local streets and such. So we had kind of a little bit of experience with kind of this integrated corridor management process. It was much more focused on kind of signal operations and traffic operations, so it didn't have the transit component to it, but it was, kind of a precursor to what we looked at in 2007 then. Couple of challenges with this is that once the system was actually deployed, there was a lot of questions on maintenance and operations, especially kind of on the local system. And a lot of the technical staff were maybe supportive of the concept and the idea, but some of the elected officials were maybe not quite as supportive and concerned about detouring basically interstate 494 traffic onto the local system. And, I think that's where it's very important to bring those type of stakeholders on early, that even if you've got representatives from your city and county, that it shouldn't just be your technical staff, but also some of those policymakers and those elected officials too, to make sure that they're on board. Because, really the intent of the system was to not necessarily send traffic to the local system on a daily basis, but was rather intended to kind of manage those major incidents when 494 was closed. And I think if they had maybe a better understanding of that this traffic's going to get detoured anyway because it's a major incident and the freeway might be closed or severely capacity reductions, that there might have been a stronger appetite to kind of keep this system. So if you drive through these corridors today, you'll see a lot of these alternate route signs. You'll see a lot of these little mini DMSs on the signal arms, but they haven't actually worked in a long time. As signals have been replaced or interchanges have been rebuilt and these signs have come down, we haven't bothered putting them back up. So maybe about half of them are gone just because of that, but they're kind of a dinosaur from a project of yesterday. So that was kind of one experience we had, and that kind of you know, gave some people a bad taste of like, well, do we really want to do this again on a different corridor? But then others were kind of like, well, no, I think there was a lot of lessons learned there. And, you know, how can we kind of take this to a different corridor in Minnesota? And so at the time, we decided to focus on the 394 corridor, and this was more in the Western Metro. And here we had an interstate going down the middle again, but we had two parallel highways, Highway 55 and Highway 7, as you see highlighted there. And part of the reason for shifting corridors, you know, why not just try again on 494 and rebuild that project or get that off the ground again? Some of it was is to maybe kind of focus a little bit more on some fewer partners, fewer municipalities involved, and also the fact that 55 and 7 are both state highways and within MnDOT's purview. So maybe it was a bit better of a project or a pilot project. However, I will say once 55 and 7 come into the city of Minneapolis is responsible for all the signal operations within their city limits. So even though it's a MnDOT highway, so we did involve City of Minneapolis. So we had a pretty large partner there, and we did have Hennepin County involved too, because these orange routes, which were kind of the connector routes, with the exception of 494 on the west end here, and 169 and 100. Some of these local routes here were county roads that kind of serve as those major connectors that kind of connect the dots here between the different segments. So our existing network, we had multiple operations centers. We had our freeway management system, our arterial management system, our 511 traveler information. We had kind of a unique situation with these ABC garages. These were garages that were actually built right over the top of the interstate back when Interstate 394 was built. They're actually owned by MnDOT, and they're operated by the city of Minneapolis. And revenues from these garages can actually be spent back into the corridor for either transit or HOV related projects. And there's major incentives for HOV users. And so those were built like in the early 90s and when the corridor was constructed, and is a nice kind of focused audience for some of our traveler information. So that was kind of a unique aspect of this corridor. We had multiple transit networks. We had mainly Metro Transit, which provides the majority of the transit systems throughout the Twin Cities, but we also had a couple of suburban carriers as well, Plymouth Metrolink and Southwest Transit. So we involved them into the development of this project. And then we're also running a hot lane, high occupancy toll lane or min pass lane on this corridor as well. So here's just a list of the stakeholders. I've kind of talked through those already. I think the only one I didn't touch on was obviously including our Minnesota State Patrol, who was the primary responder for most of these routes. We do have a couple of local agency law enforcement and fire departments that were involved too. We brought them in a couple of times, but they probably weren't as big of a focus as maybe the stakeholders you see listed here, at least not at that time. So our first task was developing that concept of operations, and I think as most folks know, with kind of a systems engineering process, it's kind of your first step to really identify those needs and problems. This was relatively new to a lot of folks back then, and we had these meetings with local stakeholders, and a lot of them wanted to focus right away on the technology. They'd ask the question, well, you're talking about putting cameras out there. Well, what's the need? What's the problem that you're trying to solve? Why would we put cameras out there? Try to get away from that kind of technology aspect of it, and really try to set the goals and objectives for the corridor before we kind of dig into those ITS solutions. So some of the needs that we developed, and I'm not going to necessarily read through all these word for word, you can kind of see it in the PowerPoint that Julie sent out. One thing I'll notice, I did some kind of major revisions, so I'm kind of the one that caused her to have to send out the second version there. So make sure you're kind of going off the second version. There's some other details in the first version that you can certainly look at, but that's the one I'm speaking to today, is the one that she sent out later in the morning. So we had a need for kind of that corridor-wide traveler information. We had really strong traveler information on the freeway network, but really had a lot of gaps in the arterial network. Weren't really providing good information on what was going on those corridors, and wasn't really providing good information on what was going on at the transit level. What were bus travel times? What was the parking red lot availability? And so some of those needs were kind of identified right off the bat. We want to look at better travel time reliability. So this is certainly where our incident management comes in, and this is where we would have brought in our partners, mainly focusing on State Patrol because they are kind of the primary responders of a lot of the routes listed there, but bringing in those county and local agencies too as needed. One of the things that we kind of discovered was when we had like a major interstate closure and we'd reroute things to the local system, is that the signals folks, whether it was city, county, or state, didn't necessarily have signal timing plans that were, ready to deploy at a moment's notice should there be a closure on the system. And so one of the things we looked at doing was having kind of closure points along the interstate so that we'd say, okay, if we're going to have an incident between here and there, this is going to be where we're going to shut it down. And if we shut it down there, that's going to mean that signals folks are going to have to implement plan 23, whatever, number plan it was. And we found that the same thing was true for transit, in that transit was oftentimes having to adjust on the fly to kind of our closures and our incidents, and having to reroute their buses. So, again, having like kind of transit plans that would kind of go along with those closure plans, so that they would have something that could go on the fly, because they talked about having to get all their supervisors and such together and kind of looking at a map and trying to draw things out on the whiteboard in the conference room, trying to figure out where they're going to relocate their buses to, with a lot of the express service that was on Interstate 394. So having kind of those pre-planned, and so there might still need to be some tweaks, but at least you've got kind of some foundation to start with. And then we needed to provide some incentive for transit users. So we looked at transit signal priority, we looked at park and ride lot availability, providing that information to the public either through signs or web applications. And then transit was looking at kind of a transit decision support system as well, which was something that they ended up deploying as part of this 394 project. They were able to secure some funds, just some normal operating funds, but through just kind of the development of the ICM corridor and the partnerships that we had between us and them, they were able to really kind of make the case to their management that this was something that was needed that would help them manage their transit system better during different events and different traffic conditions. And they're doing things like pulling in some of our incident data out of our 511 system so that it pops up into their transit decision support system, so they can kind of see that all in kind of one user platform. So that was kind of something that did spin off pretty early on in the ICM development process, that they were able to secure those funds and justify it just kind of through this project. And that doesn't just serve the 394 corridor, but it serves the entire metro area that Metro Transit serves. We had a need for corridor-wide monitoring of conditions. At that time, and a lot's changed in the years that have passed since this, that our system was really focused on the freeway. We had detection on the freeway. We could tell you volumes, we could tell you speed and all that sort of good stuff. We had cameras on the freeway, changeable message signs, but really nothing on the arterials. And so that was kind of a paradigm shift for MnDOT, especially, we were starting to really kind of finish up the freeway management system in the Twin Cities metro area. And so what was kind of the next step? And so it was really kind of looking at those arterial corridors and trying to maybe do similar types of instrumentation on those. And then once we'd have these systems, is how do we integrate with those transit systems? So providing access to our video to the transit agencies, providing access to our incident messages and such like that, like I mentioned, feeding that into a decision support system for them so that they would have a better sense of what was going on the system real time. And one of the things we found really useful is that it was really kind of hard to just talk in general. Well, what do you want? What are the needs? What are the problems? What goals and objectives we have? We kind of took a step back and developed these operational scenarios and kind of walked through these and said, okay, if we had a major incident here, what's going to happen? What's your agency going to do to respond to that? And that's where we were kind of finding out all these things, like I was mentioning earlier about, well, when MnDOT and State Patrol decides they're going to close it here, we're quickly working to try to figure out how we're going to adjust our signal timing or how we're going to adjust our transit routes. And we're doing this all on the fly. And it's like, gosh, that seems like something that's pretty easy to remedy, and just having some thought to that and putting some plans together. So that was kind of one of the initial stages that we kind of developed. And, and just kind of walking through the rest of these, you can see they all kind of vary from major incidents to minor incidents, having some on the freeway, some on the arterials, having incidents related to transit, having those big major events that could occur, and changing based on time of day, weather events, because, snow happens in Minnesota for sure. So, how do these all kind of affect our plan, and were there gaps that we had in our concept as we walk through these, like, oh, it worked really well for scenario 1, but hey, now we're down in scenario 10 and we've identified some new gaps and stuff like that. So our next step was to kind of start to piece together what would the system do, and so we got into this development of system requirements and trying to define, that the ICM system shall do this, shall do that. Um, Still kind of not necessarily looking at the how, but that we want system-wide coverage so that we can see what traffic volumes are like out there. Well, what does that mean? Does that mean that we're going to go with a probe data type solution or more sensor data type solution? Still haven't got to that step yet, but just identifying that there's a need to get volume data or get speed data or something like that. We also kind of identified that we didn't really want to develop a new system in terms of like a back office system or server system, but we wanted to look at more of how can we take advantage of the systems that we have and integrate them together by maybe developing some enhancements or modules to existing systems and having them communicate together. So we didn't want to create like this kind of third-party system that, there was the question mark of, well, who's going to maintain that? Is that MnDOT's? Is that the counties? Is that the cities? Or are we all chipping in? It's kind of like a consortium. Instead, we kind of made it, well, everybody kind of is responsible for their own piece. And so we talked about, like, on some of these boxes here, you'll see on the top, there's like State Patrol CAD system, county emergency management system, city emergency management system, systems at the ABC garages, systems on the public works side from the state to county and city, and then also transit systems here on the left and such. So, if everybody kind of builds their own module and communicates data back and forth, does it go through a central hub, or is this more of like a virtual hub? A lot of the stuff we've set up now has been more of a virtual hub, so we don't have that kind of need for this circle in the center. It's almost more of a cloud type of thing. So like in the example of where MnDOT traffic operations is sharing data to the transit control center system, that's not passing through like another third-party system to get there. It's just a direct kind of connection. So we wanted to try to keep our kind of maintenance and operations costs as low as possible, to ensure that the system would have more longevity. So getting into some of the lessons learned, and some of the things that we did kind of spin off from this project. As I said, we developed this concept of operations. We kind of tested it in a modeling simulation, developed those system requirements for kind of what it was we wanted. And there's more details that I didn't get into and how we were kind of going to break that out into different sub-projects, so that we could tackle it in different ways. We had sub-projects related to arterial traffic management and transit and traveler information. And I know it sounds kind of funny to have a holistic project and then you break it up into silos only to bring it kind of back again. But, that was kind of how we wanted to kind of deliver the project as time went on. So since a lot of that, since we didn't get kind of the federal funding, we kind of shifted our priorities a little bit. At the same time that we were developing this ICM project, there was the urban partnership agreement proposals that were submitted at that time to Federal Highway as well. And those had kind of some similarities in looking at, traffic management and congestion pricing and teleworking and transit all kind of combined along with the technology. So there was a lot of concepts that came out of this ICM that ended up getting kind of deployed as part of the UPA project. And the UPA project kind of shifted our gears away from I-394 ICM to basically our 35W corridor that ended up being our corridor for the urban partnership. And so that really kind of occupied a lot of our resources and our time for the next 2 to 3 years after we had kind of developed this. And that's another reason why we kind of shifted away from the original concept on 394. But like I said, we took some of those concepts that when we were focusing on it at a corridor level and applied them more to a system level. So one of the things we kind of identified right away was, we need to look at probe data. And we did a solicitation. Took us a while to get there. We had kind of cold feet jumping into the probe data world. And I think Iowa, you guys jumped into it a lot sooner than we did. And you guys have had INREX for a number of years. We finally jumped into that with HERE data. So we're using HERE data now and have data for both our arterial system now as well as our freeway system, really covering the entire state highway system. And then also a lot of the local major roads in the metropolitan area. Doesn't get down to that granularity when you go out into the rural areas, but certainly in the urban areas, they were able to provide us data on a lot of the major county and city roads. It doesn't get down to all the residential routes, but certainly those major routes that we'd be interested in, especially for an ICM corridor. So we're using that not only for reporting tools. ClearGuide is actually the reporting tool. It's provided by Iteris. And so Iteris and HERE collaborated together to submit a proposal on our RFP, and they were the ones who won the bid over INREX was the other bidder. And we're also integrated that with our Iris software. Iris is our control software that we use for controlling all of our message boards, our ramp meters, our min-pass system, basically any of our field devices really related to our ITS system is controlled by Iris, with probably the exception of like our traffic signals being controlled by like MaxView. But otherwise, everything else pretty much kind of falls in that Iris bucket. So we integrated ClearGuide with Iris so that ClearGuide can calculate some travel times using the here data and then spit that off in real time for Iris to then deploy that on our message boards. So on the freeway system where we got good instrumentation, we're still using our traffic sensors for that. But on some of our arterial corridors and some of our rural recreational routes where we got a lot of cabin traffic in the summer, we're starting to use that here data, and that's still relatively new. We just launched it just a few months ago, so still trying to figure out how well it's going to work. And of course, with COVID having volumes down, we haven't really been able to kick the tires on that as well as we'd like. But maybe as we get into the summer months and it looks like traffic volumes are increasing, we should be able to kind of test that out a little bit more thoroughly. Another thing that really kind of helped out of the ICM project is it really improved agency coordination. We built a lot of kind of partnerships and relationships with the agencies that were involved in this, and then try to continue to expand that to some of the other partnering agencies out there. So not only related to traffic incident management, but really kind of helped on some major incidents we had as well. We had the 35W bridge collapse shortly after this project was developed, and really kind of helped that a lot of the partners that we were working with on this ICM project were the same partners that we had to deal with on the 35W bridge collapse, and trying to figure out, all right, how are we going to reroute traffic for the next year? So even though we didn't have like ICM implemented yet, those relationships were there and ready to go. And right around that same time, I think it actually happened before the bridge collapse, we had this big tanker rollover that had happened right at the interchange of 394 and 94, which is on the eastern edge of our ICM. And so again, just some of those relationships being fostered already helped kind of manage that better, because we were shutting down two major interstates right in the downtown Minneapolis area. And we've had a number of special events too, built a new Viking stadium. So there's always the regular events that happen at US Bank Stadium. But then because it was a new stadium, we were fortunate enough, or maybe unfortunate enough, I don't know, this depends on the perspective, got both the Super Bowl and the Final Four in back-to-back years. And so that took a lot of planning and coordination with a lot of these same partners. And so able to maybe build upon some of those relationships and strategies that were being developed as part of the ICM project, that we could kind of steer towards those major events. And then in the area of arterial traffic management, this was kind of a real paradigm shift for us, as I kind of mentioned earlier, that a lot of our focus had always been on the freeway system. We've been installing cameras and detection and ramp meters since like the 70s, and really did major rollouts more in the 90s. So doing freeway management system was nothing new to us, but arterials, we just never really did anything with, other than your standard signal controllers and those types of systems, but didn't have like a camera at the intersection to watch that signal timing, didn't have fiber optic communications, those type of things. So this map, I know it's probably a little bit hard to see, but everything in green is kind of the freeway management system, and everything in blue is the arterial management system. And the kind of thinner lines are the ones that are funded and completed, and then the other ones are kind of those ones that are still we're still pursuing funding for, the ones that are kind of the thicker line, that's either the thicker blue or the thicker green. But at any rate, you can see a lot of those blue lines, a lot of those arterial corridors. I think they probably have about 100 to maybe 150 miles of arterial corridors covered now, whereas in the ICM days there was 0 miles of arterial traffic management systems. So we kind of spun that off from this ICM project. The first one to be instrumented was actually Highway 13, because it got instrumented as part of that 35W UP8 project, and that corridor was kind of related to 35W and provided as a feeder route to it. But then once we finished that, then we went back and we completed the 5 and 7 corridors, which were those parallel routes to 394, and kind of building upon that original ICM concept. And then from there, we just kind of kept going around the metro and kind of highlighting various corridors to add further instrumentation on. So on those corridors, we'll have fiber connectivity to all the different traffic signals, as opposed to having them use dial-up, so they can access those signals in a much more efficient manner. And then having the cameras at the signals so that they can monitor conditions out there. And then also on a few of these routes, having changeable message signs to warn motorists of maybe either conditions on that arterial, or conditions on an adjacent freeway route. Kind of getting back to some of the concepts that came from that original ICTM project. So, and that's really been kind of most of our focus has really been on kind of that arterial management. It also gave us the opportunity as part of the UPA project to also try out some transit signal priority, which was an idea that was kicked around as part of the ICM project. We were able to deploy that on Highway 13 as well as Highway 65 and test out some transit signal priority on those corridors because we were adding these type of systems and having the infrastructure there with the cameras and the fiber optic. On the transit side of things, a lot of those concepts developed for ICM were looking at those park and ride lot availability, giving people the sense of how many stalls there were available or how many spots there were available or whether they were full, and having these signs on local roads as well as even on the freeway. And also having travel time comparison signs and next bus arrival signs. So you can see some examples here in the pictures. This would be a sign that's, I think this one's actually on a local road as you're coming up to an interchange for the freeway. And it would say freeway time to University Avenue down near Minneapolis. And that would tell you, the difference between car and bus. They must have taken this picture during the off-peak when the time was the same, which is kind of unfortunate. Should have shown a little bit more of a difference there, but the intent was to, show that difference of how buses would have a better travel time than car and start to, encourage folks to make that transition. Whoops. The next one, then we have this kind of park and ride sign, and this one, would either say full or available. Wouldn't actually give like the number of stalls, but just showing that it was open and that there was space available. And so we had these on Interstate 35W rather, showing that the availability and kind of these travel time comparisons. So it wasn't just on like the local or county roads, but also even once you got on the interstate. So if you were approaching an interchange that had a park and ride and there was express bus service out of that park and ride, you'd see some similar signs to this. And in the downtown area for more of the return trip, as they're getting back on the bus in the evening, there's signs that show next trip arrivals when the next bus will arrive. And so that was kind of all done as part of the 35W UPA project, because that's kind of where we got the federal money for the grant. But a lot of the emphasis from that was, again, from that 394 corridor and some of the brainstorming that was done there. And then I had my little, systems of systems with all the little boxes connected to each other, and felt I needed to throw in a even more complicated diagram here, but don't, worry about trying to figure all this out. I mean, for the most part, what I was trying to show here is a lot of that thought of having those kind of systems of systems and getting systems talking to each other is kind of highlighted in here, and kind of where we've been and where we kind of continue to plan to go. Since that time of ICM, our car system is our central system, very similar to Iowa. We have Castle Rock just like you guys do. So the DOT folks are familiar with cars and 511, but cars being kind of that back end, and then 511 being the interface that the public sees, whether it's the website or phone number or a smartphone application, and then spitting that out to third parties. So kind of the receivers of the data are more on the right-hand side, but all the inputs are more on the left-hand side. And so back in the day, it used to just be Iris, our control software, feeding into cars. Well, now it's our CAD database from State Patrol and our maintenance decision support system, and we've even had like arrow boards feeding into our system, and then looking at trying to adopt other kind of technology and other kind of smart systems out there in the corridors to continue improving the amount of data that goes into cars and eventually out to the public or out to our other partners as well. So one thing that I've got a lot of the third-party partners, but I really should have kind of that bubble for transit, like I talked about earlier too, feeding that data to transit too. So again, just kind of building off of those concepts. And so that kind of concludes where we were at with 394 and the ICM, and kind of how that maybe sparked, projects that were more kind of regionally focused and not necessarily on that particular corridor. But I wanted to kind of just touch on a couple of the other kind of active traffic demand management systems in Minnesota. Kind of added a few slides here after seeing some of the presentations on Tuesday. But ramp metering is something that we've had historically for a long time, and I think it's still continued to be one of the better tools in the toolbox, I think, in terms of cost effectiveness and ability to manage traffic. So we haven't expanded as much in recent years, but we do occasionally add maybe 2 or 3 more ramp meters on various corridors, maybe every 2-3 years or so or something like that. So it's not necessarily a kind of a corridor wide because we've kind of completed the system, but still kind of focusing on, you know, maybe 1 or 2 more interchanges as congestion starts to grow more in those outlying areas. So when it comes to, you know, questions about, well, how do you get kind of public support for it and stuff? Unfortunately, we're probably not one of the better states to ask in that regard because they have been around for so long, and people have kind of become to understand them of what they are. Doesn't necessarily mean they like them, but they, you know, they at least kind of understand them and stuff. So we'll do some kind of local focused efforts, but you know, our efforts aren't probably as detailed as maybe some other states that are trying ramp meters for the first time in a region. We've also done our smart line system. We did that as part of 35W in the UPA corridor. We then expanded it to I-94 between the 2 downtowns. There we deployed kind of these intelligent link control signals like you see in the picture here. We had a total of 297 of these, and they rolled out between 2009 and 2011. So that was a lot of devices that were kind of thrown out there in a very short window. To put some perspective of it, I think we had at that time about 200 changeable message signs throughout the metro. So these are basically like mini changeable message signs, just using them more as like lane control. So, you know, really more than doubling the number of signs that we had to maintain, which was a challenge because we got 0 staff added to our operating budget, both on the maintenance side as well as on the operating side. So that was kind of a challenge right off the bat that we had to try to do, you know, that inevitable more with less type of thing. So we, you know, looked at how could we automate the system as best as possible in our Iris control software, making it easier for operators to control, and then also had a maintenance contractor with the vendor to maintain these signs on the 2 corridors. They could deploy variable speed limits like you see here in the picture. Was really kind of more of a queue warning system than like a speed harmonization system. We'd kind of be warning people of congestion ahead and trying to get them to slow down and ease into that congestion. We could also deploy incident messages, so kind of the X's and arrows, and could also put some text messaging on there too, kind of relatively simple text messages saying like lane closed ahead. And we had a dynamic shoulder on 35W that we used these lane control signals to show when that dynamic shoulder lane was open or closed. We ended up taking these down in about 2018, so they lasted for about 10 years or so. A few different reasons for that. One was the vendor that we had was a company out of Spain called Imago, who at that time had just acquired ADCO out of Minnesota here. And I'm sure a lot of you are familiar with ADCO and that their kind of bread and butter is making portable message signs. And we had a lot of kind of maintenance issues with these signs because the technology, even though, you know, it was a local company that was helping with the support, but the technology was really kind of coming from Spain. And so we had issues with them not working so well in some of the Minnesota weather, especially on the cold days. We had a lot of reliability and dependability issues with them and a lot of pixel failures that were starting to happen at kind of that 8 to 10 year mark. Imago ended up kind of going under. A lot of it having to do not only company issues, but also issues like with economy in Spain and stuff like that that were kind of impacting them. And then that of course hurt ADCO here locally as well. Ended up kind of dropping the maintenance contract. ADCO has since kind of come out of that okay, which is great to see. The local company has still kind of survived, but they're kind of saying, no, we're gonna stick with our portable message signs, and this wasn't really our technology anyway. So we basically kind of lacked a vendor, so we, you know, didn't have any more spare parts. We had to cannibalize some of the corridor to keep other parts of the corridor up and running. We did that probably starting at about 2015, 2016, where we kind of shut off like some of the outlying areas and cannibalize those signs for spare parts to keep the higher volume sections running. But then by 2018, we just decided it was time to pull the plug on the system, that we were getting too many failures. We had you know, no additional staff, but it was taking probably the equivalent of 2 FTEs to maintain it, and we didn't have kind of that vendor support anymore. So we talked about replacing it with a different vendor. We use LEDStar for most of our changeable message signs, and LEDStar has something that could have been deployed and put on these gantries, but we kind of opted not to. Instead, we've kind of gone to a smart lane light, that I've kind of dubbed it, where instead of these lane control signals every half mile, we're doing kind of mini DMSs every 1 to 2 miles. And so we can still give a lot of the same information, but with a fraction of the amount of technology out there. Probably a third of the cost to the system, but maybe it doesn't get you 100% of the benefits. Maybe it's like 80 or 90% of the benefits, but at a third of the cost, that's it's a much better benefit cost ratio for us. So that's why we ended up pulling it and not really going back to it. We did run the dynamic shoulder lane for a little while longer within that stretch, but that section had always been planned for reconstruction. The dynamic shoulder was only intended to be a stopgap until that full reconstruction was supposed to happen in 2025. That project actually got moved up to 2018 and is finishing up this year. It was a 4-year construction project. So it's actually adding that 5th lane, so we no longer need to operate the 5th lane as a dynamic shoulder anymore. This is actually a picture of that. I guess got ahead of myself a little bit. This is the dynamic shoulder lane section. And so it was this left lane here. It really acted as an extension of our min-path lane because we had a major project, built 5 lanes up into this point of this picture. Whoops. And we were still 3 miles short of downtown, because you can see the downtown skyscrapers there in the background. And so that was going to create this huge bottleneck and not getting the min-pass users and the transit users to downtown where they wanted to be. And so we were able to use the dynamic shoulder lane as a way to get a 5th lane in this 4-lane section. And so we shifted all the lanes to the right. So there's really no right-hand shoulder except for a few spots where there's an emergency pull-off. And then we utilized the left shoulder, then this wide left shoulder, as an extension of the min-pass lane. And we did that on the left for a few different reasons. One, the way the road splits at the end, the exits to downtown are actually on the left. So we kind of wanted that to be more on the left. You can kind of see that from the guide signs on the top. 35W actually continues on the right. And then we also did it because then we could kind of avoid the complication of having to go through interchanges and having the ramps crossing the dynamic shoulder. So as I said, this is currently under reconstruction, so we no longer have the dynamic shoulder lane. This one, though, I'd say would be still a tool in our toolbox. The idea still gets kicked around every now and then. We looked at it on a section of 494. We're currently looking at it on a section of 77, Highway 77. The 484 one, we decided to add additional capacity. 77 one is still at the very early phases of the study, so it's one of many alternatives still on the table. So it's still one that I think has a lot of benefit because you're able to better utilize the capacity on the roadway. And I think there, we would look at having kind of those lane control signals because it allows you to utilize that pavement out there and get that extra capacity by opening that lane. But in the other sections where all we had was the lane control signals, there wasn't maybe as significant of a benefit. So that concludes my presentation.
Thank you so much, Brian. At this point, we are open for questions for Brian on his presentation. So as a reminder, you can utilize the Q&A panel if you are joining our online meeting. Type in your question there and I will read it out loud to Brian. Or if you would like to ask your question verbally, you are welcome to raise your hand. So look for the hand icon for our online meeting attendees. And if you are dial-in only, dial *3. Well, Brian, we do have one question already in the Q&A panel. Lee Smith is asking, does Minnesota DOT use the yellow arrow for ILCS?
Yeah, that's a big question, and it's been kind of one that there's been a lot of debate on. We actually used a couple of different ones, and I don't have that slide. Unfortunately, I should have thrown that one in here. We had a merge with a chevron on it. So it actually said merge in 14-inch characters, and then underneath it, it had a sequential chevron, much like you'd see on the back of a DOT truck. And so we kind of felt, well, you can use it on a DOT truck. Why can't you just pretend like the DOT truck's floating over the ground there? Our local federal office actually agreed to it. And then it kind of came down the pipe later on that we really should have done a request to experiment on that. And the problem was we had already deployed it because we thought we had the green light from our local federal office. So I don't know if there's a miscommunications there or what happened. I'm not going to necessarily point fingers, but just somehow we ended up kind of deploying it without kind of that official approval and that official request for to experiment. We then submitted our request to experiment, and kind of the feedback we got was, well, we're not going to tell you no, but we're not going to say yes either, and that it's going to continue to be researched. And so there has been a number of research studies done to it. We did some of our own kind of human factor studies to see how well it worked, and there's been some that have been funded by more of the national level. And there was kind of this, debate between us and Seattle. We actually worked a lot with our partners at WashDOT because we were developing this system at the same time that Washington DOT folks were doing it as well. And they had also won the UPA grant. And we were kind of having a friendly competition of, who could build it first. But the thing is we had a lot of conference calls with them, to try to say, well, what are you doing and how are you doing this? And, how are you taking these ideas that we're seeing over in Europe and putting it into a system on a US highway and working with like your regional office of federal highway and stuff. And so we had a lot of those kind of back and forth conversations and really built a very strong relationship with the folks out in the Seattle area with Washington DOT and they were using, instead of the merge with the chevron, they went with more of that downward angled arrow, and that one too was not one that was approved. The human factor studies did look at kind of both of those, and they actually found that the angled arrow was getting a little bit better response than the merge with the chevron. It wasn't like a huge difference, but definitely showed a little bit of an improvement there. But yeah, that's still not an officially approved message yet. So hoping that one would someday get in there, because I think either one, I don't know. I guess I'd have probably a little preference to the merge with the chevron, but I think either one could work. We have one that's a flashing yellow arrow. It's a downward arrow, just kind of like the green arrow you see there. It's a flashing yellow arrow that we use as more of a use caution message. And we'll do that like over a lane that maybe has like debris in it, that the lane's not actually closed, but, use some caution. Or it might be used for the right lane when there's an incident on the right shoulder, as again, kind of that slow use caution. And that's something that we've used outside of our Lowry Tunnel since like the early 70s. And it's in our Minnesota manual, but it's not in the federal manual. And so we've gotten a lot of other states that have kind of said, gosh, we'd really like to use that too. And it's kind of gotten grandfathered in for us with Minnesota, but that's another one that hasn't really been adopted yet by the federal manual. And we find it's still pretty effective because we do still have some lane control signals, not like these. They're just more of the smaller, less dynamic, where you've just got the different icons available. We have those outside our Lowry Tunnel on I-94, and then we also have them on a bridge on Highway 52, but nothing like what you see in the picture here.
Thank you so much. We have another question from Kevin Brown. You mentioned staffing challenges with operating the ATDM. Has Minnesota DOT had any challenges with operations and maintenance funding for these types of active management strategies?
I would say yes. We never really got any increased staffing when we had these to have a dedicated person to just manage these type of systems. So we try to automate it as much as possible within our control software. On the maintenance side, we just we have 12 people that are kind of responsible for electrical maintenance of our ITS systems, and 2 of them were basically dedicated to just these lane control signals. And so, it was a pretty big decision to pull these systems out, because it was pretty visible to the public. They've been up for 10 years and all of a sudden they're going to go away. And we kind of said, we just can't keep our head above water anymore. We can't keep up with the maintenance of them. It's taking away from maintenance of other systems. And there's going to be a point that we're just not going to be able to get spare parts anymore because we don't have a vendor anymore. So what do you want us to do? Do you want us to take them down, or do you want us to replace them with a different vendor? Our recommendation was to take them down, and management agreed to that. So, but I think with like all of our ITS stuff, it's still always a struggle in terms of asset management, in terms of getting the right number of people to maintain them. I think we're doing okay right now, I would say, on the staffing levels, but still have challenges in terms of meeting our life cycle costs. One of the things we've done that's kind of worked well for us, at least like on the message signs and even a few of our other devices, is we have a master contract that we purchase all of our signs from. So we don't purchase our signs on like a quarter by quarter, project by project basis. We have one master contract, and that right now is with Lead Star, and they've actually held it for a number of years, where it's a 2-year contract with the option to extend up to 5, and we can just basically cut a purchase order to that. So if we have a construction project that needs a couple of signs, we buy a couple of signs and we provide them to the contractor to then install. And so that way we're kind of always dealing with one product, and then it also gives us the ability to purchase things very quickly. And so right now, you know, being at the end of a biennium, all of a sudden they're finding all this loose change in the couch cushions across the department, and they say, hey, Brian, I've got $1 million for you. Can you spend it by June 30th? And because I've got this contract in place, I can go out and buy like 5 or 6 signs. I'll still need to figure out like how to get SRC dollars maybe in the next year or two to install them, but the install price is a lot less than what the actual price of the sign itself is. So it allows me to be able to take advantage of kind of those end of year funds to kind of help with my asset management and my life cycle replacement. It's worked well for us. It's, you know, probably not the best way to survive in terms of, you know, you don't have like a constant funding source. So if all of a sudden there's a year where there is no end of year or end of biennium funds, then you're kind of high and dry and you're hoping for a better year next time. But that's kind of how we've kept ourselves afloat.
Thank you. Our next question, Brian talked about the ICM project and then other arterial projects later. This is mostly a question of project management and development and who does what for DOT staff. How did Minnesota DOT decide what constituted the ICM project and when it ended, since the ongoing implementation, monitoring, and maintenance of the project is ongoing?
Yeah, I'd say as we were developing the ICM project, you know, we had a project manager specific to that project, and that was actually me. It wasn't necessarily the only thing I was focused on. I also had some of the other kind of traffic operations responsibilities, but it probably did occupy maybe half my time. And the other players involved were all people that kind of had their normal job duties and responsibilities outside of the ICM, and were just kind of pulled in as stakeholders. And then we had a consultant team that helped support us. AP Creek and Alliant Engineering were the consulting team. And so they did a lot of the documentation and facilitation of meetings and such like that. But you know, we never had like a true, you know, core team. I was probably the closest thing to a full-time person kind of working on it. And then as these other systems kind of spun off from those concepts and those ideas, they've, you know, there still isn't really like a true team related to like ICM. It's really kind of, we all have kind of our pieces of it. You know, there's me on the traffic and freeway operations side. There's folks on the signal operations side. There's folks on the traveler information side. But still having kind of that collaboration effort to kind of bring all those pieces together, even though it's not like necessarily a core team that's kind of focused on it.
Okay, we still have time for some questions if there's any others. Again, you can type them in the Q&A panel, or if you want to ask one verbally, feel free to raise your hand. The raise hand icon is in between your panel or participant and panelists panel and the Q&A panel. It's a little hand icon. You click it and it will raise your hand and I will unmute you. Looks like we have a question from Neil Spiller. Neil, you have been unmuted.
Thank you. Brian, thanks for a great presentation. Do you keep a log of ICM events, or are they, do you consider them unique events, or do you consider them, you know, kind of nominal operational events? I'm asking in the context because you probably heard this before, but when San Diego and Dallas had their demonstration projects, they were required to by the tenets of the contract to keep a log and then therefore, you know, tweak ICM to make it more responsive or better the next time, I guess. Do you do the same thing, the same kind of post event, dissemination?
No, I would say we don't. Because of the fact that we kind of got away from that corridor focus and just kind of went more regional in just trying to adopt some of those philosophies and ideas, but not necessarily focusing on just a particular corridor. I would call it more in kind of that just operational event that we just do on a day-to-day basis. So, we do have records of what incidents we've had out there, where things were shut down, what our sign messages, all that stuff is like kept in a database, so we could go back and kind of extract some of that data and see when we're kind of using some of these tools and stuff. But yeah, as far as like an ICM event, we don't really track anything like that.
Okay, thank you.
Thanks for the question, Neil. Looks like we've got another question from Lee Smith. Lee, you should be unmuted now.
All right, hey, Brian, I actually put my question in the box in case I didn't get to me. I just was curious about, you may have already covered it, but the traffic signal O&M, kind of what you said. I think Minnesota doesn't maintain or operate signals. I was wondering if you guys provided any funding to local agencies or some other method of support for signal O&M.
Yeah, on the signal side, I'm more on the freeway side, so I'll kind of put that caveat out there, but I know enough about it to be dangerous. But basically, we are not providing any kind of O&M support to the local agencies at all. We're still, kind of acting independently. Our signal operations folks have got it in kind of some increases in their budget in terms of adding additional staff to their operations, especially having more real-time staff on duty. A lot of times their staff were just kind of more of the 9 to 5, and they would work from like their cubicle. But we've always had like this kind of corner of the RTMC that was like, oh, that's going to be signal operations someday. And so now they have gotten some staff to actually have signal operations staff in there during peak hours, so that if we do have like a closure to an interstate, or they've got issues on the arterial, they can help monitor that and manage the situation. But yeah, not going down to that level that we're managing or operating some of the local traffic signals. They did deploy MaxView. They did write the RFP as such so that other agencies can kind of adopt MaxView, and looking at, they have had conversations, and I guess this is probably where I'm probably stretching myself a little bit here. They have had kind of some of those conversations that if we are on kind of a similar platform with MaxView, would we have MnDOT staff have the ability to operate some of those local signals? But I don't believe any of that's actually happened, but there has been discussions to that effect. And some of those discussions did kind of come out of the 394 ICM project, because a lot of these local agencies recognize that, well, if you got something that happens at 5, 6 o'clock at night, we already went home an hour ago. So, would there be an opportunity for MnDOT staff to be able to do that? But it hasn't come to fruition yet.
Okay, thanks, Brian. Just to clarify, you mentioned the RTMC. Is it MnDOT staff on the signal side, or is it the local agency staff instead of the TMC?
It's all MnDOT staff. Yep. It's the RTMC is our Regional Transportation Management Center. We have State Patrol dispatch, maintenance dispatch, and then MnDOT freeway operations, and then the arterial freeway operations that's there now is still MnDOT staff. So they're all state agencies, no local agency partners in there.
Okay. And the local agencies been able to fund their signal O&M to a level that will, accommodate ICM or the regional ICM patterns.
Yeah, I mean, I would say, they're still funding just kind of their normal signal operations. I wouldn't call it necessarily a true ICM, in terms of having like an integrated system together and stuff like that. It's still probably being acted pretty independently. Minneapolis since that time has kind of expanded their traffic management center, having longer staff hours and being able to have more system monitoring of their traffic signals and upgrading some of their devices. But it's been probably more organically driven and not necessarily through like a core ICM projects.
Gotcha. Thanks, Brian. I appreciate it.
Yep.
Okay, if we have any more questions, we have a minute or so left. Okay, seeing none, we'll wrap this up. If anybody thinks of anything else they'd like to have addressed by Brian on Minnesota DOT's ICM efforts, feel free to make a note and take it with you for Thursday's meetings, or you can always submit it in the Q&A panel for later, and we will save it for next Thursday, session 3, or you can send an email to me or one of the other meeting hosts as well. So with that, we do have time for a brief break. So we're going to give you about 5 minutes to stretch, get a beverage, etc. And we will reconvene. It's 2:01 now, so we'll reconvene in 5 minutes, which would be about 2:06. Thanks, everyone. And thank you, Brian.
Thank you.
Okay, welcome back, everyone. Next, we're going to move on to a presentation about the Des Moines efforts, or ICM efforts. John Markt and Neil Fobian will be presenting. So John, if you'd like to take it away, you should have presenter permissions to share your screen.
All right, I'm going to wave hi, and then I'll start to share my screen. You hopefully say hello too.
Was that John? I catch that? All right. Well, good afternoon, everybody. I'm Neil Fobian with the Location and Environment Bureau, the Iowa DOT. And together with John Markt, who's with HDR and been our consultant lead on our project, we'll be presenting on the Des Moines Metro Area ICM. So go ahead and turn off my video so I don't run out of bandwidth here either. Go ahead and go to the next slide, John. So we've heard from 4 of our peer states and what they've been doing with integrated corridor management. Now I'd like to kind of give the Iowa perspective of what we've been doing. So what is integrated corridor management? Short answer, ICM is many agencies working together to balance traffic across a variety of roads and transportation modes. The ICM concept provides a framework for coordination among all the area transportation, making sure that we utilize and improve multiple modes of transportation and that we're not just looking at the freeways. It's been it's a collaboration of multiple agencies working together to improve transportation in our community as a network and not just the individual roadway segments. And this has been proven to be a more cost-effective approach than simply adding more capacity or additional lanes to the roadway. Next slide. So the overall goal of the Des Moines ICM is to make trips seamless and convenient for our commuters across the metro. We're doing this by improving safety, improving mobility, trying to improve the travel time reliability, improving accessibility, and all the while trying to improve our public vision and momentum for the project. And lastly, we'd also, trying to provide expedited project delivery. ICM can only be successful when all parties involved are working together. So that's why we've been taking a collaborative approach to this project with stakeholders from the Des Moines area, MPO, with FHWA, our local jurisdictions, and DART. And together, we're working on solutions that are going to benefit the entire metro. So this slide here, this slide here is showing our vision statement that was crafted early on that one of our first stakeholder workshops. And it simply reads that the Des Moines metropolitan area will benefit from a safe, efficient, reliable, sustainable transportation system that supports economic growth and promotes an equitable and healthy community. ICM strategies will assist the state and area communities to proactively manage multimodal transportation systems in a safe and efficient manner using proven technologies and operational strategies while maximizing the use of existing infrastructure and services. ICM will offer travelers more opportunities to make seamless and convenient trips to meet social and economic needs. So that's a rather lengthy vision statement, but I guess it's kind of what we're aspiring to with the ICM project. So why does the Metro need ICM? The Des Moines metro area is one of the fastest growing metros in the state. You can see the statistics on the screen here. The Des Moines area has grown about 12% since 1990, but Waukee grew nearly eightfold, and Ankeny has tripled it, with West Des Moines doubling kind of all in that same time frame. So the fact is we can no longer afford to always build our way out of congestion. We need to find a more sustainable solution to handle the increased traffic demands. I guess my next few slides here, I'll explain that a little further why Des Moines needs ICM. Next slide, thanks. So with traditional widening projects, they seem to focus too narrowly on the recurring congestion. So when we look at the pie chart on the right here, showing the national statistics, we can see that recurring congestion, or that the non-reoccurring congestion, makes up a little over half of the total congestion. And then when we compare that with the statistics from Iowa, which is shown on the left, you can see that we have a greater amount of bad weather and traffic incidences, making the non-reoccurring congestion an even larger portion than what's compared to that nationally. So with ICM strategies, these are more suited for dealing with that non-reoccurring congestion. So, next slide. So one of our early stakeholder workshops, we did an activity with these maps on the wall. We broke the metro up into 4 different quadrants, and we asked stakeholders to place markers and notes on the map in areas where they knew about or were some known issues. So in the Northwest here, it was noted that safety was a primary concern, with high traffic speeds around the area known kind of as the urban loop. And as we moved a little bit farther south there and come up to the US 6 or Hickman Road interchange, this area is kind of a hot spot for both high levels of congestion and need for some interjurisdictional traffic signal optimization. Next slide. So in the Northeast, emergency response was hampered by a continuous median barrier. And then we also had complex interchanges and some long stretches without any interchange access. There's safety concerns noted on 3580 and 35 heading north. In one instance, we have traffic that's stopping on the ramp and backing up onto the interstate. And in other areas, there's a need to better separate the entrance and exit ramp traffic. And then finally, there's a significant congestion noted on Interstate 80 at the exit to US 65, with the thought that this could require a dedicated deceleration lane in that area. In the Southwest, congestion on 235 is very heavy at the interchange of of Iowa 28, which is 63rd Street. At that interchange, we have some lane drops on 235, and it creates a bottleneck in that area. Safety was noted as a concern at the Southwest Mixmaster interchange, with some tight weaving concerns in that area. And then a little bit farther out, there was a need for more public transportation services to help access to some of the jobs at the Jordan Creek Town Center, including park and ride opportunities there as well. And then moving into the last quadrant in the southeast, the downtown grid is in need of improved accessibility by travelers, and also US 69 provides access to the East Village area, but we have multiple pedestrian infrastructure gaps in that area as well. So there could be a lot done there with sidewalks and whatnot to help pedestrian mobility. So some of the representative ICM benefits are improved safety and emergency response, improved accessibility and mobility, reduced or shifted demand, enhanced traveler choice and decision making, improved transportation efficiency and productivity, improved customer experience and perception, and hopefully we'd see a reduced environmental impact. But the real draw to this project started with the increased return on the existing investment. And to get there big opportunities exist for some institutional cooperation. So what does deploying ICM for Des Moines look like? So this slide shows our project timeline. In the fall of 2018, we started with our ICM visioning and then moved into some early implementation projects through 2019. Transitioning into 2020, we continued our ICM planning and started identifying some projects. And currently in 21, we've been working on our partnerships with the local agencies through some educational campaign, our working groups, and then also this peer exchange that we're hosting today. So before we can answer that question of what deploying the ICM in the metro looks like, we need to understand that ICM best operates as a system, and that system is made up of 7 different program elements shown here: event management, freeway traffic management, arterial traffic management, traveler information, infrastructure enhancement, travel demand management, and public transportation management. And these 7 elements were then used to draft our candidate ICM bundles or approaches to deploying the ICM. So we've developed these 5 different operational philosophies or bundles of strategies. And those 5 are the aggressive freeway build, intensive transportation management, transit and travel demand management, a balanced approach, and targeted transportation management. The first approaches or bundles were drafted and with focus on some combination of roadway capacity, TSMO, and transit capacity. The roadway capacity focused on through capacity and our system interchanges for the 35, 80, and 235 loop. TSMO was directed at selecting from the 7 different program areas, and transit capacity focused on vehicles and transit infrastructure. So the level of emphasis then of each program area was determined for each of the individual strategies, and that's kind of depicted in the graphic there. You can see the little dial with the number on it, indicating kind of the level of investment of those 3 different categories. So then each bundle was evaluated using safety tools, traffic operation and reliability models, and some case study research along with cost benefit analysis. Next slide. So after reviewing the analysis with our stakeholders, the preferred bundle selected was most closely aligned with bundle number 2, which is the intensive transportation management. We were seeing or looking at the aggressive freeway build to add capacity and new infrastructure to fully build out our system to handle the 2050 traffic volumes. We were looking at an estimated cost of like $2.76 billion. And then comparing that with the balanced approach, which was going to be kind of Iowa DOT business as usual with ICM strategies added in, we were only seeing a slight savings of like $2.3 billion. So this is why Bundle 2 was looking like a better way forward, because our regional analysis showed that by focusing more heavily on ICM strategies, we could get the best benefits or returns with a significant reduction in cost. So with that, I am going to go ahead and turn it over to John Mark now, and he is going to talk a little bit about our implementation plans. John, if you want to go ahead.
Yeah, thanks, Neil. So as Neil's talked about, extensively here, this is a presentation that shows that we are, building ICM from not a lot of existing capabilities to manage the system, and that the vision that we worked out with partners in early 2019 really is a pretty aspirational vision, and so we had to look at how we could build out from the existing case. We need to build emphasis on our, kind of our stakeholder relationships. We needed to build capabilities to the system. And so you can see here that this first place that we're looking at is a few different projects that fell into this early implementation category. We felt like that was really critical to talk to our partners and figure out how to address some of the needs that they had, and work with projects that could quickly show the advantage of operational improvements. And so you can see here that these early implementation issues, we directly went back to our needs assessment, and then we pulled out kind of some of these things that Neil was talking about more closely, and said what are the strategies we need to start with, and we'll build out from there to really have a more fully functional ICM. And so we started with median barrier gates, and then also some enhanced information at system interchanges for dispatch. Those are both, projects really helpful to, that partnership with emergency management services. Then we looked at improvements to exit ramps to help with queuing back onto the interstate, and also improvements to just that parallel system of arterials, making sure that signal coordination across jurisdictions so that we can get travelers to use those parallel facilities to the freeway. And then finally looking at kind of what are some of our other major issues on the freeway corridors and travel sheds. One of them is dealing with the major national freight patterns that cross through this area, and how can we address heavy vehicle traffic. And so looking at those heavy vehicle traffic restrictions during the peak hours. So we took those physical type improvements, but with operational strategies, and we've placed them on a map here so that you can kind of see how we're crossing over our different ICM toolbox areas, and how we're spreading out across the metro, because this really is a metro-wide operations project. It's not just corridor management for one corridor, even though there needs to at the corridor level be plans to kind of deal with how you adjust for load balancing of traffic. And so we started to move beyond those early implementation projects and move into some other strategies that would take a little bit longer to get into the system, but that bring us to having more of those operational capabilities. So you can see here, for those that are familiar with the area, that on the 235 corridor, which is kind of that lower green line. We have some ramp metering. It addresses that bottleneck that Neil was talking about on the Iowa Highway 28, kind of being the dividing line between where 235 has some lane drops. So ramp metering to really help with the inflow and outflow peaking, and also using those kind of adaptive capabilities with ramp metering in order to balance how freeway access occurs to help under certain situations. Also looking at that Interstate 3580 corridor, there's two different sections there. The north-south portion, just near on the map where it says Clyde, looking at Q warning in order to help with travel right now. It's very heavy in that outside lane with a lot of ramp access points. The DMS messages that'll go up to help with that kind of messaging through traffic to stay to the interior lanes also provides a lot of flexibility for alerting traffic to major incidents. And then on the east-west portion of 3580, we have recommendations to look at dynamic shoulder use, using the inside shoulder since they've already been built out to be full width, full depth, so that we can use some of those lane use control signs specific to just that sitting over that shoulder lane to allow traffic to use it as we see breakdowns when we have either really heavy traffic or we have an incident on the corridor. So for those who aren't very familiar with our potential strategies that we talked about for Tier 1, I'll just go through each in a rather quick fashion. This is ramp metering. Obviously, the situation here with the ramp meters is that they help with safety. 235 has a tremendous amount of peak hour crashes, which, a lot of them are minor, but they do have a ripple effect on the entire system. The ramp metering will help because it can measure our speeds and occupancies on the freeway to help restrict the travel access via ramps when congestion is already really severe on the freeway. Under more typical conditions, it can just act as that safety benefit, allowing travelers on the ramp to be spaced out so we don't have big breakdowns right at the merge point. Again, second strategy that's of interest is this dynamic shoulder use. We really developed an approach that makes dynamic shoulder use flexible to be used for congestion or incident only, or using it for different vehicle types, potentially transit. The line on the map that I showed you on 3580 is focused on kind of using that dynamic shoulder use for passenger vehicles in the inside lane. Again, because it will help operationally improve, how we can move traffic through that area without having to do a major widening project. But still, other dynamic shoulder use projects that may come along down the line that could use some of these other, elements you see in these pictures, like focusing on carpools or transit only. And then the Q warning sign, again, these are signs that are going to really help with the kind of alerting to those stop conditions ahead. Again, 3580 has significant safety patterns, and then also just poor use of the multiple lanes that are on that corridor with a lot of traffic, having short trips or nearby exit areas, so looking to stay to that right-hand side and trying to balance that traffic out, in addition to having the flexibility to alert traffic to when there might be a full closure. So again, as we push forward with the ICM, we've also worked to develop kind of where recommendations might go beyond that first tier of freeway improvements. And then after I get off this slide, where we have a lot of the specific locations, I'll get into some of the non-location specific improvements that are part of the management strategy. And so you can see here that we've just extended some of the strategies to new areas. Ramp metering is on a second corridor on 3580, tier 2 improvements. Dynamic shoulder use is on a second corridor, 235. That particular improvement would be, quite a bit of traditional widening with shoulder use potentially being how you manage that widening instead of going to full lanes or full criteria rebuilds. And then you can see that on 3580, where we start out with the kind of smaller sign footprints for the dynamic shoulder use, we would look at potentially doing dynamic speed advisories that would help with some of the conditions here. Again, kind of frequent heavy vehicles that are involved in crashes also have situations like severe weather and that major bridge area that can cause the need to alert people to slower speeds. So both weather and congestion could be uses for that dynamic speed advisory. This is a little bit closer look at a couple different ways to deploy dynamic speed advisory. Again, these speeds are going to be not regulatory in Iowa, but would help with kind of alerting travelers to behavior changes, needing to slow a little bit earlier because prevailing conditions are poor due to inclement weather or incidents or congestion. So getting a little bit off the freeway and focused on some of these other strategies that are looking to move forward, one of the ones that we see as being hugely important for the Des Moines area is transportation demand management. The growth, as Neil talked about, is a real reason why starting towards this vision, towards integrated corridor management now, can only help with kind of improving how the system is used before we see a lot of growth on the fringe that then leads to a bunch of single occupant trips on the freeways and nearby arterials. And so there has been some good investment in demand management in this area in the past, particularly with early 2000s with the Interstate 235 reconstruction project. And so definitely one of the things that this ICM will look to do is reinvest in those past demand management campaigns and work on working on that employer side, but then also some potential on-demand strategies in order to help with managing the demand to what traffic capacity can handle at a time. Elements that'll be part of that, connecting people with van pools, both long-term and dynamically, transit modifications, moving those shorter in trips to non-motorized modes, and then, as we've seen with the pandemic, moving people to telecommute options. Another major part of the Iowa focus on operations and an integrated system is really funding more so this traffic control system. I know it was mentioned by one of our other panelists, but sometimes states don't operate the signal system, and so this has to become a partnership where everybody has different responsibilities. Here the cities in Iowa will operate their traffic signals, and so there really needs to be some improvements in funding, and it's still a learning curve as to how that's going to happen. But in order to make optimization a more frequent and more focused topic, looking at those areas that are for sure on existing incident routes, so that we can get adaptive traffic signal control deployments out there to help balance how much of the system will automatically adapt versus how much is having to be managed day to day. And then looking at transit signal priority as well. Again, while we have kind of a regional focus on our strategies, we know that the Interstate 235 corridors is a major part of what is driving this ICM. And so a transit signal priority, looking at kind of a regional strategy, but focusing that to the University Avenue corridor where there's already really good use of the DART system, and could be some opportunities for making that roadway a little bit more transit friendly as well. And so move on to kind of a part of our integrated corridor management that isn't as much on the technology side or operating strategy, but making some improvements to infrastructure that are spot improvements targeted on the arterial system. One of the things that we're looking at here is using alternative intersection designs, those more primary intersections, trying to avoid a system that requires us to build in out of context interchanges when we might be able to maintain kind of that at grade, but with some of these alternative elements. The other part of this is looking at access management and really focusing on how improvement of those access management principles can improve safety, which then keeps us from having an incident condition that has a clog on the system. Part of what ICM is doing in Des Moines to really help move this along is working on a prioritization process with all of the partners in order to get some of the existing funding streams that are out there dedicated even more so to the task of system optimization. And then kind of the last thing I'll touch on is, again, our ICM is very early. We're adding a lot of the base capabilities, but it's also just building that working partnership. So a lot of ICM's focus in this upcoming year is on making sure that all of the agencies have kind of a core working relationship, both at the planning stage so that there can be joint funding going forward, and then also the operating stage. So we have 3 different working groups. They've been meeting quarterly as we continue to look at, how formal does ICM become. We feel like these groups will create champions in each agency that understand the benefits of ICM and really contribute towards it. So our first is personal mobility, which really focuses on our goal area of accessibility. The second working group is the Green Light Working Group, which focuses really heavily on reliability of the system and more of our signal components. And then our Freeway Solutions Working Group, which again is focused really heavily on safety and making sure that every time we have an incident, that we have really safe conditions for our responders to get that out there, but also hoping to drop the number of crash incidents, both the severe ones and minor crashes, and keep people safe. I'm going to hand it back to Neil, who is going to wrap us up here.
All right, thanks, John. Yeah, so summing up, ICM is a more proactive way to manage the existing transportation system in a more cost-effective manner than our traditional methods. Partnerships that we have been working on will increase travel safety options and reliability of the transportation system in the metro area. And the early implementation strategies are addressing existing needs, and those can be rolled out pretty quickly. The mid to long-term strategies will address our ICM vision across multiple facilities and modes of travel. Next slide. For more information, you can visit our project website, which is shown in the link there, or it's iowadot.gov/Des Moines ICM. And here, you'd be able to sign up for some various notifications, be able to view our ICM video, have access to some educational awareness material that we've been in the process of developing to share with our stakeholders, as well as you'd be able to read some of our approved project reports that are also available on the resources tab on our website. So with that, I guess I would open it up for any questions.
Thanks, Neil and John. We do have a question from Lee Smith in our Q&A panel. He says, John, I see that your DSL is advisory, not regulatory. What was the decision matrix for that? And was enforceability a factor?
Yeah, so definitely as we have been putting this together, we worked through, kind of the normal concept of operations process. We started with the overall program concept of operations, and Liz Jacobson, who's going to be speaking next, really led that process. And then we moved into more of a ConOps on the, advanced through and management strategies. And as we worked through, kind of the scenarios, definitely it seemed like, we were getting feedback from, the enforcement agencies, either from history and then also just from kind of their current capabilities, that, that wasn't really going to be a very feasible option. And so as we kind of tailored the scenarios, we did focus on kind of where can we use just advisory speeds so that, we're actually bringing a benefit to the traveler themselves. You know, we would have enough information on current conditions that they would need to be slowing down anyway. So it's always really salient information, and that's why they would react to it the way they would. But yeah, I think the ability to enforce was a major consideration in focusing on the advisory side of things. And I think that, you know, this being a new strategy here, you know, there's a little bit of having to prove it on the salience of the information so that people are, you know, have seen it and get used to that before they would be comfortable moving towards being enforced in that way.
If we have any other questions, oh, there's Lisa's. Thank you, John. If we have any other questions, you can type them into the Q&A panel, or if you want to ask them verbally, feel free to raise your hand. As a reminder, for those of you on the phone, you would dial *3, and those of you on the online meeting, look for the hand icon and simply click that.
All right. I think our audience must have you know, heard all they needed to hear. So, Julie, I think maybe we can. Looks like we're a bit ahead of schedule, but we probably can afford another break. And then we could get into the presentation by Les Jacobson. So, do you mind breaking us?
Not a problem. We will take another brief 5-minute break, give you a chance to stretch, get a beverage, etc. So since it's 2:42 now, we will reconvene at about 2:47. Thanks, everyone. Welcome back, everyone. At this point, we are moving on to Les Jacobson, who's going to be presenting on some ICM evolution and emerging trends. So Les, I have passed the presenter capabilities to you, so you should be able to get going.
Thanks, Julie. As Julie mentioned, I'll be covering kind of the evolution of ICM and some of the emerging trends, really looking at where ICM started from, and then where perhaps it appears to be headed based on some of the newer applications there are around the country. Okay, I hope you're seeing my slides now.
Yes, we are, Les.
So what I'll be doing is first kind of talking a little bit about how the ICM concept developed, and then going into especially the pioneer demonstration corridors. Brian mentioned that they were one of the pioneer corridors that in the, I don't know, 2006, 2007 timeframe was when those were selected, and then looking at how ICM has broadened out beyond the demonstrations, and then some of the emerging concepts and trends, at least in my view, what some of those may be. So the concept development really started about 15 to 20 years ago, probably closer to 15. There was some foundational research and development of the concept. that addressed separation of responsibilities and control that was in place in the transportation network. So we have various agencies, various jurisdictions. We have different modes controlling different aspects of the network, and that made it difficult to really operate the system as a whole. It really couldn't be done holistically. So that was one of the things that was kind of one of the reasons to take a look at this. The other thing is that's especially noticeable when there's major incidents or events or any unusual conditions. That independent operation of portions of the transportation network could be seen that it was just not very effective. So there's several things that are included here. One is if you want to implement signal timing plans, you might have to go across several jurisdictions. Perhaps the agency that first sees the need doesn't have signal timing responsibilities at all. Also, coordinating ramp metering and signal operations makes it difficult in kind of the way that the responsibilities are spread today. Also, getting traveler information out about everything in the network is difficult when there's a lot of different pieces that need to be centralized in order to disseminate a clear picture. There may be needs for things like changing parking restrictions or changing bus service or adding buses. Anything like that, especially in these major incidents, made it really difficult to operate the network as efficiently as it could. So there were some very strategic areas that were kind of included in this discussion. One was, how do we manage demand on the network? And how do we balance travel demand across the network, not just across the different facilities, but across all modes? And as we mentioned before, event and incident response was important. And also, how do we get capital improvement to the facilities that need it the most? So as part of that concept development, there were several different conceptual levels, kind of the physical level, the network, the infrastructure, those sorts of things. There was also information processing, so kind of the logical side of it. How do we put all this together? How do we share information? What sorts of decisions need to be made? And then there's the execution and actually making those decisions. So the networks that were identified are things like freeways and arterials and of course the public transportation network. So USDOT initially identified 8 sites. Brian had a map of where those are. I'm not going to go back into where the locations were, but it was really used to help kind of focus on the operational concept, to how to manage the corridor as a system rather than those individual pieces of the network and the individual assets. It also was looking at how it could help travelers make informed decisions and dynamically shift modes, especially how well could that be done? There's been talk about that for a lot of years, but it's a very difficult thing once someone's made a decision on a particular mode to then change to a different mode. Also, the operational concept wanted to look at reducing travel delays, certainly fuel consumption, emissions, and reducing incidents and collisions. It was about that time, maybe a little bit earlier, that travel time reliability and predictability became really important. So one of the things that was seen that integrated corridor management could do is maybe help to improve travel time, reliability, and predictability. And then also the operational concept was looking at how do we best optimize the existing transportation infrastructure. So how do we use what we've already got most effectively? Through those demonstration sites, those 8 sites, there was a down select to 2 corridors for a demonstration, a pilot demonstration of the ICM concepts. One was in the US 75 corridor in Dallas, and the other is the I-15 corridor in San Diego. A lot of you probably have read about this, maybe even seen the ICM corridors in these 2 locations. They've certainly had an awful lot of visibility, and they really did some groundbreaking work in what they were doing. So I'm not going to spend a lot of time on these, but I do want to give a feel for what these corridors were. So US 75, the corridor was the freeway. It had continuous frontage roads. There were also arterials in the same corridor that could be used both parallel and then kind of across the freeway and linking the different parallel routes. There's some high occupancy vehicle lanes in the corridor. There's also the Dallas North Tollway that was part of the corridor. It has a bus network, light rail. There were about 900 traffic signals in the corridor, and there were multiple transportation management centers that would need to coordinate and collaborate and work together in the ICM. Also in the Dallas area, there was a regional 511 system. And so they saw the importance, both corridors saw the importance of decision support, and how do operations staff and how does the system make some of the decisions, especially across different modes, different types of travel. And so it became really clear that there needed to be something more than just a straightforward computer algorithm that would optimize everything. And so a decision support concept was put in. I'm not going to go through all of the ways that either of these systems did decision support, but I think it's important to know that they had things programmed in that would help operators make decisions on what needed to happen in the corridor, and some of those decisions could be automated. And they found benefits like improved travel time reliability, enhanced decision making, and a 20-to-1 return projected over the project's 10-year life. San Diego was similar in a lot of ways. It had a primary freeway corridor. It also had a managed lane system, which was a little bit different than the HOV system in Dallas, but still had another roadway or lanes that could be managed. There were a lot of institutional relationships that were built, partnerships. One of the important things that both of these corridors found was how important it is to get the different agencies together, to get agreement on how the corridor would operate overall. There were some multimodal transportation improvement strategies, and especially to look at how they could try to improve mode shift. There's bus rapid transit. There's also signal priority that was used in the corridor, and also had a 511 system. So in many ways, these two corridors have a lot of the same sort of assets and facilities that they could use in their ICM program. Their decision support system was a little bit different. They used what they called response postures that would look at what the demand on the network was and what the impact of the event might be, and then would kind of with a matrix like that come down and help to determine what sort of response through the decision support system there might need to be. So both of those corridors went live in early 2013. There were independent evaluations done on each one, and some of the lessons learned from the early days, and I think these are mostly the same lessons today. We mentioned I mentioned how important it was to get agreements. It's not always easy to get those agreements in place. That can take a lot of time, takes a lot of effort, takes a lot of listening and participation to make sure that everybody's views are met and we can come to an agreement. They felt that this was the most challenging part of ICM. Also, data integration from multiple systems and multiple networks was difficult and needed to be really thought out. I think today it might be a little bit easier than it was back then, just because of some of the additional technology and ways to kind of integrate data that really weren't in place back then. Also, even determining mode shift is difficult because of all of the different factors that are going on. There's a lot of different things anytime you look from day to day or week to week, and so looking at what might have happened in terms of mode shift based on some of the strategies was really difficult to do. And then kind of similar to that, when you have a lot of strategies, which ideally you'd implement a lot of strategies on the network when there's a problem, or even when there's not a specific problem, but you're just trying to optimize the performance. There's a lot of different things that are done, and because of those combinations of strategies, it can be really difficult to evaluate, especially one strategy versus another. So as those demonstrations were being undertaken, a lot of other agencies also looked at ICM. Kind of like Brian mentioned, they did the planning, and then they looked at, okay, how can we learn from that ICM planning? There were a lot of other agencies that looked, maybe hadn't been one of the pioneer sites, but had seen and heard about ICM programs, and so they wanted to, seeing the benefits, they wanted to try and embrace the concept. And the focus kind of varied. Some of them were traffic incident and event management only. Some of them worked on a bit of a broader utilization of the network on a daily basis, and how could they balance flows or balance demand overall. And then there was some emphasis on demand management concepts, but those demand management concepts varied from implementation to implementation, or program to program. So some of the other ICM corridors that were put into place, or projects, Michigan had a couple of pilots, one on I-75 and one on I-696. They were really event-based. So they looked at how in a under a major incident or other event, special event perhaps, or major construction project, how could they improve response to that? And they looked a lot at traffic rerouting onto arterials, and when traffic diverted, how could they kind of make that diversion as efficient as possible. They provided some ITS equipment upgrades, and then they also filled in the devices where there were gaps. They also looked at signal timing on those alternative routes, and the models anyway showed that freeway recovery times were increasing by 15 to 30 minutes. So again, Michigan really focused on that event kind of scenario. In the San Francisco Bay Area, the I-80 corridor east of San Francisco, there was a 20-mile segment. It was led by the Alameda County Transportation Commission, but it had Caltrans, MTC, and many local counties and cities were all part of this ICM effort. It included adaptive ramp metering, incident management, a lot of active traffic management overall, variable speed signs, lane use signs. There were improvements to arterials, especially improvements to communication to signals and the ability to update and modify traffic signal timing. And they had an operations and maintenance memorandum of understanding among all these different agencies, 9 different cities that were included, and 2 counties, Alameda County and Contra Costa County, and also 2 transit agencies. So this was a really major effort. I think you can go online and search for I-80 Smart Corridor and see some of the things that it has done. That kind of led California overall, first the San Diego ICM effort, and then the I-80 effort really kind of had California DOT, Caltrans, really look at how they operated their entire network. So they kind of changed to a concept of managing their networks through corridors. They call them connected corridors. They have a statewide framework. They started this program in about 2011. And their whole organizational structure actually was modified around this connected corridors concept. And you can see some of the things that were included: connected and automated vehicles, looking at connecting infrastructure in the corridor. Again, they looked at enhanced decision support, a very important aspect of it, and they incorporated social networking as well. So the first corridor that they looked at was the I-210 corridor. I'm not going to get into a lot of detail here, but it was a pretty complex corridor with freeways on either side of it, a lot of arterials, and and transit routes, and they looked at how they could work together within this pretty complex environment to improve the operation of the corridor overall. A lot of that work has kind of led to some of the things that some of the newer ICM efforts have looked at and are embracing and incorporating. I think we're starting to see a broader set of strategies. There are a number of ICM efforts that are now looking at how do we make transit more take on more of a role, or maybe I should say, how can we support transit in taking on more of a role and trying to increase mode share? Things like automated shuttles that might provide first and last mile connectivity. What's the role overall of connected vehicles? How do connected vehicles play in the ICM arena? Also shared mobility. So how can that kind of sharing notion be utilized within a corridor? And certainly mobility on demand, or mobility as a service, is also some of the strategies that are more being incorporated in some of the ICM efforts and programs now. And because of that, even though if you look at how broad the stakeholder group was in Dallas or in San Diego, there's even a broader set of stakeholders in some of the emerging concepts. And that's not an easy thing to kind of manage when there's not only transit agencies and local agencies and counties and the DOT, but you start to look at mobility management agencies and many more private partners. It can be a lot more daunting to try and have that good stakeholder involvement. But that points out the importance of partnerships. And also, one of the things that's coming up is as I alluded to earlier, is incorporating advanced technologies and how advanced technologies can support the ICM concept overall. One of the newest and maybe the one of the most kind of far-reaching corridor efforts is in the San Francisco Bay Area. It's called Innovate 680. It's in Contra Costa County. And what they're looking at is addressing growth overall in the corridor through a set of strategies that are essentially ICM strategies, if you want to look at it that way, without any sort of significant infrastructure expansion. So how can they use the existing assets that are available for transportation more effectively? It's got a very collaborative stakeholder process. There's a lot of effort that goes into that with a lot of stakeholder partners. It really has a decision-making structure, I think, that is similar to what is done in Des Moines, where there's kind of an overall kind of ICM steering committee, if you will, and then that also has some kind of strategy type or facility type committees that are part of that as well. They also have a program level ConOps that talks about how everything will fit together. It's a pretty robust set of concepts. And it's all tied back to their basic goals to improve safety, efficiency, reliability, to prepare the corridor for the future. They have a very strong kind of focus on shifting travel modes and to improve connectivity and services among all of the different mobility options, and certainly increasing and providing more mobility options and improving air quality are important, and also promoting equity and to provide access to transportation services across the community as a whole. So they have a set of 7 initial strategies. So kind of cooling corridor hotspots, that's looking at where there's bottlenecks and what can be done to reduce those bottlenecks. It's a lot like in the Des Moines ICM program, looking at that bottleneck removal kind of aspect of the program. They want to complete the HOV and express lane system, make sure they're linked together, make sure that those facilities also support the overall corridor program. There's a strategy to improve bus service efficiency. They are focusing a lot on how they can use innovative operational strategies to meet their goals. They've got a big focus on transportation demand management, also on first and last mile connections, and how can they do that better so that people can get to a good location to join transit, and then at the other end get to their destination well as well. And then all of this kind of works together to help prepare the corridor for the future growth, for future technology that might be coming about. Those are all really important concepts that they're working with in Innovate 680. So they have several current projects that rely on those strategies. They have a project that is specific to advanced technologies. They're developing a decision support center through that. They also have a connected data center that's bringing data in from all of the different partner agencies and having a central location to manage that data and also to use that data in operational decision making. They have a coordinated adaptive ramp metering program that is looking at some of the strategies that have been kind of pioneered in Melbourne, Australia, and bringing those to the corridor. They're looking at mobility on demand with a kind of a traveler-oriented mobility as a service platform, so that there's kind of one location that travelers can go to and then plan their whole trip, eventually have payment for their entire trip, things like that. Very personalized, that it's not run to serve a particular agency, but really to serve the goals of the individual travelers. They also are looking at shared mobility hubs. There's a project on that now. It's kind of multimodal transportation nodes, and it's looking at how best to interface with between micromobility and the transit service, especially. That's where this first and last mile will kind of come together with transit service. They're also looking at part-time transit lanes. So this could be in various locations, kind of like dynamic shoulder use, except specifically for transit and not necessarily on freeways. They're also looking at automated driving systems. This is especially for things like automated shuttle service that will allow that first and last mile connection, and other types of connected vehicle technology as well. And as I mentioned earlier, they're looking to complete the express lane system in the area. So that's the Innovate 680 project. And again, I think that's an example of where ICM is heading to be more multimodal, to include more stakeholders. But I also wanted to point out that really that is kind of one direction. I think the other direction that ICM is heading, that you can see from some of the different projects that have been presented here, both on Tuesday and then again this morning, is that there's not one size fits all, and not everyone is going to be doing the same thing with their ICM programs. So it's really about finding the mix of strategies that will work best in your corridor. And I think that's what we're going to see more of, maybe even broader diversity in the future among ICM programs than we've seen in the past. So with that, I'll end and see if you have any questions.
Thank you, Les. We do have one question already. How are corridor limits defined? An expert panel, or do you just know them when you see them?
I think that's kind of as much about the stakeholder involvement and what stakeholders view it to be. I think there's always going to be kind of a core limited number of agencies that get together and say, you know, let's focus in this area, and how broad the corridor gets kind of depends on, and even how long it should be, kind of depends on I think what the geographic area is. I don't think there's a standard way to figure out how to kind of bound the corridor. Maybe someone else out there has a different idea, but I think it's very much location by location, and certainly more art than science.
Thank you. And it looks like Neil Spiller has his hand raised. So Neil, you are now unmuted.
Really, and Les, you're right. It is more of a art than a science. We use the term travel shed to define those trips that are common or germane or affected by that mainline trunk, the trunk line. I mean, let's go back to one of the earlier slides that somebody had earlier today, that Brian had, that showed, you know, US 75 as the trunk line, and then drawing a cordon around it. Anything outside of that cordon really can't be considered within that corridor, or can't be considered a trip that would be, you know, diverted or rerouted or rechanneled or even, you know, changed by mode. Think of it this way. If you think of I use the Washington DC area or the Houston area as a, you know, it's a radial network around Washington DC. There's a radial network. You have the Beltway, of course, but you also have a string of roads going from the suburbs in. You have Connecticut Avenue, Georgia Avenue. You have I-66 coming in from the west. You have I-95 coming in from the north, also from the south. You have US 50 coming from the east. Each of those defines itself as its own corridor. So any kind of a trip that might be common or germane to US 50, it has absolutely nothing to do with US 66, you know, on the other side of Washington DC area. So any, you know, if you think of the Houston radial network as a pie-shaped network, anything in the northeast quadrant has nothing to do with anything in the southwest quadrant. So the area tends to be what we define as a travel shed, and we define that travel shed as any trip within that travel shed that could or should or would find itself on that mainline trunk, in the event that mainline trunk was free and easy and you know, was at free flow speeds. But as soon as that mainline trunk suffers a problem, then they're going to have to find some way past it, through it, or around it. And that travel shed is that defined area, you know. And again, it's not absolutely defined. It never could be. And the stakeholders therein would be different as they would for the next corridor over, or the third corridor beyond that. The group of stakeholders would be different. So that's kind of the way that we would define it.
Thanks, Neil. Looks like we have another question in our Q&A panel. Les, how do you view the role of decision support systems, DSS, in ICM in the future? AI supported, conventional oh my goodness, microsm supported? I probably butchered that word. I'm so sorry.
Well, I think that absolutely we're going to see more AI supporting all of our transportation decision making, but especially in an ICM corridor. So I think decision support systems will get a lot better because of AI. That doesn't necessarily mean that there won't be micro simulation involved as well, by the way. So I think there could be uh, uh, that incorporated in, and artificial intelligence could be even based on some simulation.
Thank you, Les. We have another question. Who in the Innovate 680 partnership is the lead on the connected data center?
Ooh, I'm not sure who the lead for that actually is. Tim Hawley is the overall program manager with Contra Costa County Transportation Commission, but I don't know if there's a you know, who is leading up the connected data center. But I'm sure Tim could answer.
And Neil has raised his hand again. Neil, you are unmuted.
Yeah, thank you. Just to remind folks that in the read aheads that were prepared for this workshop, there's an item in there from FHWA that talks about the DSS, the previous question, decision support system, and it equates it to the chessboard concept, that the chessboard is the geographical constraint. The pieces on the chessboard are the stakeholders therein, and each of those stakeholders, each of those pieces on a chessboard, just like each of the stakeholders, brings something unique and different to the table. So just having the game and the game board doesn't solve your problem. Just, you know, there's 1,000 or more, million or more, you know, chess solutions, and to be a chess savant, you have to understand a lot of different strategies. And the DSS is the thing that puts that all together. So anyone who's interested in reading how the DSS incorporates as a decision support system for ICM, there's a read ahead that was provided. There's also a larger a document that was taken from, and that document is of course on the FHWA Office of Operations Managed Lanes Corridor website that talks about ICM. So if you really want to delve into that, I invite you to read that. Thank you.
Thanks, Neil. We still have time for any questions. And our other presenters are still available too if you thought of other additional questions. And again, you can type them into the Q&A panel, or you can go ahead and raise your hand. Neil, go ahead.
One more, Julie. I'm sorry to be such a bother. We do have a FHWA video which is on YouTube. So if you go to YouTube and you search integrated, I think you have to if you type in ICM, you'll come up with 6 different things. But if you actually type in integrated corridor management, you'll come up with our video. That's a singular video that we put together for leadership to explain to the leadership what the ICM concept is, and there's guest appearances by people in Dallas and San Diego who put in their 2 cents, which is fine and great. There's also another video series that we're working on that hasn't been posted yet, which is a 6-part series about ICM. I hope to have that up very soon, and I'll do a little promo shout out that next Thursday, next week, when I have an opportunity to do a brief presentation, I might share one of those videos from that 6-part video series that specifically talks about one element. But in the meantime, anyone who's interested can go to YouTube, type in integrated corridor management on the FHWA YouTube website, and there's a nice little, I don't know, 6, 8, 9 minute video, which is really meant for leadership to explain the ICM concept. I'll try to
Just a,
I'll try to back down now, Julie, and
I just
lower my
wanted
pants.
as an unsolicited opinion. I think that's actually a really helpful video. So if you haven't seen it, I would echo and support what Neil said, that it's worth taking a look at, and it's worth having other people who have, I don't know, 5 or 6 minutes to watch it. It's not overly long, but I think it does a pretty good job. So Neil, congratulations on that. I thought it was well done.
Thank you.
Do we have any other questions from our attendees today? For Les or for John or Neil Fobian, or Brian Carey is still around for questions as well. Okay, I'm seeing none. John or Neil Fobian, do you have any final remarks for today?
Yeah, Julie, thanks. I guess I just want to thank everybody for joining again. I really appreciate our speakers this session and last session. We definitely have had a really good sharing of different state practices, and then also on the concept itself. We'll meet again for session 3 next Thursday, and that meeting is going to be quite a bit different in that we are going to have the same speakers up towards the beginning of the meeting, where we'll be doing a quick panel discussion, asking some kind of common ICM questions there. But then we'll have a portion of the meeting where we'll get into breakout rooms of 6 or 8, probably closer to 8 people per room, and really kind of look to you, the audience, to give feedback on what you've gained from this, what can be useful for Iowa more broadly, or different parts of the ICM in the Des Moines, different partners who are on here, and then even maybe from our partner peer state agencies, if they can join that part as well. So that'll be kind of our next session. We'll focus on that there, and then we'll report back out, and then we will wrap up this peer exchange. But looks like we got done a little bit early today, but I really appreciated the group, and I think with that we can adjourn a bit early here.
Thank you, everyone.